afternoon, welcome to Maths Live. I've already got some shout outs to Elliot, Sam, Rio, I've already forgotten one of them, I'll have a look in a second. Harry, that was it, Harry. Here's your starter challenge. So you've got to order these fractions from smallest to biggest. Got 3 ninths, 1 quarter and 2 sixths. Now remember, yesterday we were comparing 2 fractions. Today I've given you 3. The hint I can give you with this is think about a multiple of 9, 4 and 6 to be able to do this. Because can you think of 3 new fractions that have a common denominator in order to let you compare them? I'll let you give it a go. I'll be back in a few minutes and I've done some more shout outs. Hi Maxwell, hi Josh, hi Hallie Beth, hi Lucy and Nen. So just remember that you need to, when you're ordering and comparing fractions, the denominators need to be the same. So how are you going to make those denominators the same? Hi Tom and Broughton. Hi Kian and Norwich. Hi Naomi. Hi Kitty. Okay, I've got some answers, but let's have a look. Do we want to give anything away? Oh, been busy this morning. I've done a lesson this morning, a non-live lesson, which will be going up this weekend. So that'll be exciting. Where's my board rubber gone? It's run away. Here it is. Here it is. So we need to order them from smallest to biggest. So remember that. So, common multiple. Keeping a number that's in the 9 times table, the 4 times table and the 6 times table. We're going to start with the 9s. So 1 9 is 9, 2 9s are 18. So 1 4 is 4, 2 4 are 8, 3 4 is 12, 4 4 is 16. No. 3 9s are 27. 4 9s are 36. So 1 4 is 4, 2 4 are 8, 3 4 is 12, 4 4 is 16, 5 4 is 20, 6 4 is 24, 7 4 is 28, 8 4 is 32. 9 4s are 36 and 6 6s are 36. So we've got our common denominator, 36, 36 and 36. Okay, what did you do to 9 to make it into 36? 9 times 4 is 36, so do the same to the top. 4 times 3 is 12. What did you do to 4 to make it into 36? 9 4s are 36, do the same to the top is 9. What do you do to 6 to make it into 36? Times it by 6, do the same to the top, that is 12. So we have found that these two are equal and 9 is the smallest, so it's 9, so 9 is the smallest. So the order, if I get rid of this, now remember, if you're ordering, you've got to go back to the original fractions. It's not these ones you're ordering, it's these ones. So the smallest is a quarter, and then these two are the same, so it doesn't matter which way around you put these. Okay, you've got 2 6 there and 3 9s there, okay? So remember, you're trying to find that common denominator. Bit trickier that one than yesterday, don't worry. It's getting those brains warmed up right today. Mixed and improper fractions. I love teaching this. Something you'll mainly do in year 6. If you're not in year 6 and you haven't heard of this, don't you worry. So, mixed fractions. Mixed fraction is when you've got a number and a fraction. So for example, you've got 3 and 1 quarter. That is a mixed fraction. Whole number, fraction. An improper fraction is, I was working with Harry this morning, and we were talking about improper fractions. He's only in year 4, and I was saying when something's proper, something is right. So if you do something properly, you've done it correctly. So if your parents ask you to make the bed properly, you do it properly. So improper is the opposite. So it's not right, it doesn't look right, it doesn't seem right. And an improper fraction is when the numerator is smaller than the denominator. We're used to fractions where the number at the top is smaller than the number at the bottom. But it looks weird when you have, say, looks weird, doesn't it? That's an improper fraction. And today we're going to learn how to convert between mixed numbers and improper fractions. What is the same about both of them is that they're more than a whole. Normally we talk about fractions as being less than a whole. So if we divide a pizza into quarters, we know we're splitting it into less than a whole. Mixed and improper fractions are all more than a whole. So in that example, I'm going to use pizza as an example. Let's say that I ordered 2 pizzas, okay? And the pizzas themselves were split into 6 parts. Okay, I might be really, really hungry, and I might have a whole pizza, and I might have another 4 pieces of the other pizza. How greedy am I? It might be a really, really small pizza. So I've had there 1 whole pizza, okay, because you've had 6 out of the 6. If you've got 6 out of 6, that means you've got 100%, you've got whole. So 6, the total thing, that means 1. If you have 7 out of 7, that means 1. If you have 200 over 200, that is the same as 1. It's 1 whole. So I've got my whole pizza, and then the fraction of this pizza out of the total of 6, I've had 1, 2, 3, 4 pieces. So I have eaten 1 4/6. Okay, so in my mixed number, that's what I've eaten. I could also write it as an improper fraction though. So the denominator is still 6 because we've split it by 6 parts. Let's count how many parts I've eaten. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 4/6 is the same as 10 over 6. They're linked. Now that's me showing you in pizza form. Now I'm going to show you how to do it when you haven't got the time or the space to draw a pizza or a chocolate bar or so on. Imagine I've been given 2 1/6 and I'm asked to put it into an improper fraction. First thing to remember is the denominator of this improper fraction needs to be the same as the fraction that you've been given. So it needs to be 6. The denominator here is 6, so the denominator in my improper fraction also needs to be 6. Right, so I've got 1/6. I've also got 2 wholes. 1 whole is 6 over 6. So 2 wholes is 2 lots of 6 over 6. So 2 is 6 over 6 plus 6 over 6. So 6 over 6 and 6 over 6, that's 12 over 6. Plus my 1 over 6 is 13 over 6. So basically what I've got is 6 over 6 plus 6 over 6 plus my 1 over 6. And that's 6, 12, 13. Okay, I will do another one because I was going to move on to do it the other way around, but I'll do another one. I might have 5 1/3 and I need to do it as an improper fraction. Right, I know straight away that my denominator needs to be the same as the denominator that I've started with. I know that 3 over 3 is 1. I've got 5 wholes here, so it's actually 3 over 3 and 3 over 3 and 3 over 3 and 3 over 3 1, 2, 3, 4 and 5 3 over 3. So 3, 6, 9, 12, 15 plus that extra 1 over 3 is 16 over 3. Now you might be thinking, Steph, is there another way that I can do it rather than having to write out all that? There is. Because what you'll notice, if you multiply the whole number there by the denominator, so 5 times 3 is 15, that is 15 over 3, okay? Add your 1 is 16 over 3. Okay, I'm going to show you another example. I really want to make it as clear as I can. So, we're thinking of another mixed number. I'm going to do 3 over 1/5. Okay? So, watch this time. I don't know, I'm going to change. I've already done the 5th, haven't I? I'm going to do 2 sevenths. 2 sevenths. So, I do 3 times 7, which is 21. So, I already know my denominator needs to be 7. So, 3 times 7 is 21 over 7. And then plus my 2, so 21, 22, 23. 23 over 7. So that's a quicker way of doing it. Other way around now. I've got my improper fraction, 13 over 4. So this is going to be a whole number and then a leftover fraction, which is the same denominator. Now, this time, I'm thinking, this is what you could do. You could do 13 dots and then find out how many groups of 4 are there. But we're past it. We did dots in Key Stage 1, didn't we? What you could do, 13 divided by 4. How many groups of 4 are in 13? So 4, 8, 12, and then there's 1 remainder. So that's your answer. You've got 3 whole groups of 4, 3 whole groups of 4, and 1 left over. Okay, I'll show you again, show you another one. So you might have 25 over 7. Okay, so your number is going to be something over 7. So I'm going to think about how many groups of 7 in 25. So 1 7 is 7, 2 7s are 14, 3 7s are 21. So 21, so that's 3 remainder, 21, 22, 23, 24, 25. So there's 4 left over. So my answer is 3 wholes, and then there's 4 out of those sevenths left over. Okay? Be interesting to see your comments now. Again, don't worry. We're still going to practice this. We'll still do the challenges. Right, the 3 questions, the 3 challenge questions I gave you before this lesson were, you get a pizza delivery. Okay, you get a pizza delivery. And the pizzas are all split into quarters. So the pizzas are split into quarters. Okay? You get 5 quarters. Can you draw this? Can you draw what your 5 quarters would look like? The second question is 1/3 plus 1/3 plus, I think I've seen this before, haven't I? I've just done this, haven't I? So 1, 2, 3, 4, 5, 1, 2, 3, 4 plus 1/3 equals something over 3. That was the main question. I did give you an extra challenge about converting it into a mixed number, so we'll come back to that. And question 3 was 5 and 2 over 5 is the same as what over 5? Those were 3 challenge questions. Give them a go, and I'll come back in a couple of minutes. Wow, so many comments. Scrolling back, scrolling back. Okay. Brilliant. Yeah, don't worry if you're new to this. Like I say, it's more done in end of year 5, definitely in year 6. Good. Good, well done. Brilliant, well done, you're doing really well, guys. You're doing really, really well. Yes. So I can see a lot of you have done 2. I'm not sure about the 3rd one. That's okay. So let's have a go. So for question 1, you get 5/4 of a pizza. Draw it. 2 ways you could have done it. So you said you had a pizza delivery and they were split into quarters. So you find what 5/4 is. There's 1/4, 2/4, 3/4, 4/4, 5/4. That's one way of doing it. Or you could have drawn it and then you didn't have to have the whole. So if you've done it that way, or if you rubbed it out and just had the 1, 2, 3, 4 and the 5/4, that's absolutely fine. This one, so you're just adding the 1/3 to make how many thirds? So 1, 2, 3, 4, 5. So that's 5/3. If you wanted to do it as a mixed number, that would equal 1 and 2/3. Okay, 1 and 2/3. Because you've got 3/3 and then plus your 2 that are left over. Now this one, if you're not sure about this one, don't worry, because obviously we've only just looked at it in the introduction. So we're thinking we've got 5 wholes and and then there's 2/5 and it's going to be over 5. So what you do is you multiply the whole number 5 by the denominator, which in this case is 5 again. So 5 times 5 is 25. Then we add the 2 that we've got left. Don't forget it, because that's a critical part of fraction as well. So you 5 times 5 is 25 plus the numerator, which is 27/5. Okay? Okay. Given there was a little bit of confusion, I know it's tricky this. I'll do 2 more models and then I'll give you a go. Okay? I'll do 2 more quick models. Because we don't always have to be going straight on to the next bit. If I can help any more and do any extra modelling, that's absolutely fine. So I've got a mixed number fraction. Actually, I'm going to do an improper fraction first. So I've got 13/3. And I need to make it into something and then over 3. Remember, the denominators always stay the same. So I'm making this improper fraction to a mixed number fraction. So I'm thinking about, if I know that 3/3 is 1, how many lots of 3/3 can I fit into 13/3? So what I'll do is divide 13 by 3. So 1 3 is 3, 2 3s are 6, 3 3s are 9, 4 3s are 12. Okay, another way. So I could do 3, 6, 9, 12. And I want 13. So you can see you've got 4 groups of 3/3. 3, 6, 9, 12. So there's 4 groups, but I don't want 12, I want 13. So there's 1 left over. To do it the other way around, I might have an improper fraction. I might have 2 and, let me think, 2 and 2/5. Okay, I don't want to do ones that I've already done. I've got 3 and 2/5 coming up in a minute. So 2 and 2/5. I know that my answer has to be over 5 because the fraction needs to stay the same. Quickest way to do it is multiply my whole number by the denominator. So that's 2 times 5, which is 10. Add the number that's in the numerator, which is 2. So that is 12 over 5. So 2 2/5 is the same as 12 over 5. Right. Here are your challenge questions. I'm going to do them so you're converting mixed numbers into improper fractions first, and then I'm going to do it the other way around. So you've got 3 questions each time. So question 1 is I'd like 1 1/4 as a mixed number fraction. Sorry, as an improper fraction. 3 2/5 as an improper fraction, and 6 1/3 as an improper fraction. Give that a go. Well done! Yay! Some of you are like, oh, I'll give that a go. Oh, I've got some people saying hi. Remember, shout out your name and where you're from. Yeah, brilliant, super. Hi, Soren in Bedford, thank you for joining in. Hi, Ellis, thank you for joining in. My nephew's called Ellis. I don't think we need to be talking about pizza, guys. Let's focus on the maths. Oh, well done, Maxwell. Well done, Harnick. Well done, Sam. Well done, Harry. Brilliant. Well done, Hallie Beth. Okay, right. Got lots of answers now. So 1 1/4, so you do 1 times 4 is 4, plus the 1, that's 5 over 4. Okay. With this one, 3 times 5 is 15, plus the 2 is 17 over 5. Remember, keep the denominators the same. And 6 1/3, we know it's going to be over 3. 6 times 3 is 18, plus the 1 is 19. So 5 and 4, 17 over 50. Yeah, well done, super. Amazing. So, we've had a go at converting mixed numbers into improper. Let's do it the other way around now. So I'm going to give you the improper fraction, and I'd like you to convert it into the mixed number fraction. So 3 questions again. So we've got 21 over 7, 20 over 3, and 35 over 8. Give those a go. Hi Chloe and Adam in Astley. Well done. Oh, already got answers in coming the first one. Brilliant. Hi Ethan, Mia and their mum, who are improper fractions. I like that. Right, so I'm going to wait for some. all working hard. See what there's one that's got one's a funny one. See if you can spot which one it is. All right, first answer coming in. All second answer coming in. Okay, let's have a look. Well done. It must be fun actually when you put your answer in and then someone else puts their answer in and you've got the same answer. You're like, oh, I think I've got it right. Right, let's have a go. It's like being in a classroom, but you all get to, you do the working out, but then you, rather than, you sort of like shouting out your answers, but on the computer, obviously at school, you put your hand up and say what you think it is. So, right, 21, so we know that the denominator has to be 7 and there's a mixed number. The quickest way to do it is, you could think how many, you could divide it, but this one's quite a unique one because we're doing how many lots of 7 are in our numerator. Now with this one, it's actually a whole number, there isn't any remainders because 7 threes are 21. So 7 and 7 and 7 equals 21 over 7. So it is just 3. 3 wholes. No remainders, no extra fractions. With this one, 20 divided by 3. So 3, 6, 9, 12, 15, 18. So that's 6. 6 threes are 18. How many remainders do we have? 18, 19, 20. 6 and 2 over 3. And then the last one, 35 over 8. So let's divide our numerator by our denominator. 1 8 is 8, 2 8 is 16, 3 8 is 24, 4 8s are 32. And then to get to 35 we need another 3, so there's 3 left over, 4 and 3 8s. Tricky one today, yeah? Especially if you're not in year 6, you won't really have seen this before, so well done for giving it a go. Tomorrow we're going to go on to adding and subtracting fractions. We're going to start nice and easy, really, really clear way of doing it, and then I'm going to change it so it's not as easy, but we're going to be using equivalent fractions from yesterday, so you'll be absolutely fine. If you found this alright, you'll zoom through tomorrow. Thank you for joining in. I'm going to put the challenge question up now. See you tomorrow.